Hello, welcome to today's lesson. Today we're going to look at solving quadratic equations by factoring. And I put an example here that we're going to work on in just a minute. Now, the last time we did solving quadratic equations, we used a graphing approach. And a graphing approach is very good, gives you a nice picture to work with, but we have some algebraic methods that are also very good and sometimes can be speedier. Before we dive into solving this particular equation here, I'm going to show you the zero property and refresh your memory about that. The zero property is very important. And here's what it says. If you have a situation where something times something else equals zero, okay, where things that are multiplied together equal zero, then you can make the following conclusions. Either A is equal to 0, or B might be 0, or both. That's the only way when things are multiplied together, you're going to get them to equal 0. It's called the zero property. It's a very useful way to approach something like this quadratic equation over here. What we're going to do is we're going to try and put this equation into a multiplication form where we have something times something. And that way to do it is by factoring. Now this is a trinomial. It has no common factor other than 1. So I'm just going to go ahead and hope that it factors. And if it factors, it should factor into this form where we have two binomials. So we're going to try and get the x squared. Well, that would be an x times an x. Now we need two numbers multiply together that make -4 that add up to -3. So I kept the numbers nice and easy, and I think you'll agree if you took -4 times +1 that they would multiply together to make -4, but they would also add up to make -3. Well, now we have it in a factored form, so we actually have put it in this form here. Something times something equals 0. So, here's the first something. So we can make the following conclusion. We can say that x minus 4 has to equal 0, or we could talk about the second something as equaling 0. X plus 1 can equal 0. Well, if that's the case, what would x have to be? Well, very simple to solve. X would have to be 4. And over here, we were saying that x plus 1 equals 0, then x itself would have to be -1. Well, those are our two solutions. So that's how factoring works. It's pretty quick and effective, as long as your quadratic equation factors. If it doesn't factor, this method's not very useful. All right, let's look at another example or two, maybe a little bit more complicated. Probably don't need the title anymore, so let's have a look at something like. Okay, so here's another example. 2x squared plus 3 minus 5x equals 1. Now, before we can go ahead and use the zero property, this thing doesn't even equal 0. So I'm going to have to take the 1 away from both sides, so this would become a 2. The other thing is to rewrite it in descending order. So that means the x squared term, then the x term, and then the number, which of course is now 2. So we have it equal to 0, so we can go ahead and factor and see what we get. No greatest common factor other than 1. So I'm going to go ahead and factor this. Now, there are different methods of factoring out there, and if you use a method that you've learned different from what I'm about to do, go ahead. This method's as good as any, I suppose. And what we do is we take an interim step and we write the numbers as 2x squared minus 5x, and we multiply the front with the back, which is plus 4. Now, this isn't the same equation anymore, but it's just an interim step to getting to factored form. Then I go ahead and factor the interim trinomial, and I just go ahead, it's kind of a false factoring. If there's a 2x squared, then I write 2x and 2x. It's not exactly correct, but again, it's an interim step leading us to the next level. Then I look at positive 4, and I think of what are two factors of positive 4 that add up to negative 5? Well, negative 4 and negative 1. And then my last step in the interims here is to look at what I have in the brackets here and divide each term by a greatest common factor. In this case, the greatest common factor is 2. Here, the greatest common factor is 1, so there's nothing gained by dividing each term by 1. So what would my factored form look like? Well, the 2's would cancel, and I'd be having an x, and minus 4 divided by 2 is 2. And over here we have 2x minus 1. So remember, all of this was interim stuff to getting to the factored form. Once it's factored, we're in business because we can use our zero property. If x minus 2 is supposed to equal 0, well then x could be 2. There's one solution. And if 2x minus 1 is supposed to equal 0, then if we add the 1 over and divide by 2, x could be 1 divided by 2. X could be 1/2. Two very nice solutions. So there you go. All right, let's go back and do one last example that involves a little bit of preliminary rearranging. Sometimes you will find this to be the case. How do we deal with that? Well, the example I'm doing here starts off like this. 2 over an x plus 1. Then we have plus 5 over an x minus 1 equals negative 6. Okay. In order to solve this, the first thing you have to do is clean this up and put it into a form where we've got our x squared, then our x, then a number equals 0. Right now, we have anything but that. So you want to get rid of your fractions. So my suggestion is multiply everything by x plus 1 as well as x minus 1. So every term is going to get multiplied by that. Okay. What happens is when you look at the first term, the x plus 1 on the bottom cancels with the x plus 1 that you're multiplying by. And what you have left is the 2 times the x minus 1. Okay. Then we have plus. And with our second term, the x minus 1's cancel. You're left with 5 times the x plus 1. And over on this side, nothing's going to cancel, so you're going to have minus 6 times. To make my life a little easier, I'm going to bring these together and expand them out. What we have is x squared. There is a minus x and a plus x that cancel, so I won't write that. And then a minus 1. Okay, so let's expand out the brackets a little bit more. We have 2x's minus 2 plus 5x's plus 5 equals negative 6x squared plus 6. What I now want to do is bring all terms on one side, so I have a 0 on the other. And to make my life a little easier, I'm going to start by bringing these terms over to the left side. Now, why did I choose that? Because I don't like negative coefficients in front of x squared. So I'm going to bring this term over here so it becomes positive 6x squared. Now, what else do we have on this left side? Well, we have 2x's plus 5x's. That makes 7x's. And then as far as numbers are concerned, well, I have negative 2 and 5, which is 3. But I'm also subtracting 6 over. So I'm going to have 3 take away 6, which is negative 3. Okay, so now it took all this thinking and on all these steps to get to this stage where we're ready to factor. So I'm going to go ahead and factor this now. I start off, well, there's no greatest common factor other than 1. So I'm going to do the following. I'm going to start my interim steps. All right, so 6x squared plus 7x, and then 6 times the 3 is minus 18. Then I go ahead and write 6x at the front of each set of brackets, and all I got to do is come up with two numbers that make negative 18 that add up to positive 7. So I'm thinking positive 9 and negative 2 seem to do the trick. Then I've got to divide each set of brackets by its own greatest common factor. So in this case, 6x and 9, they're all divisible by 3, and 6x and 2 are all divisible by 2. So what we end up with, I'll just give myself a little bit more room here. We'll keep our original equation down there. Well, our remodeled equation. What we end up with is we have 2x's plus 3, and over here we have 3x's minus 1 equals 0. It's always a good idea to confirm that you did your factoring correct, and it's real easy to do. 2x times 3x, yes, that's 6x squared. 2x and negative 1, okay, so negative 2, positive 9 makes positive 7, and then we're also getting negative 3, so we did our work correctly. Now comes the easy part. We want 2x plus 3 to equal 0, so I'll subtract 3 over, and then divide by 2. So there's one of my solutions. I'm going to do the same thing over here. I'm going to say, okay, I want that to equal 0. Bring the 1 over. Divide by 3. And there's our other solution. So that's pretty much the way to handle quadratic equations if you're going to solve by factoring.